Okay, from the chapter of triangles, where ABCD is a square. Though the question is from triangle, but the question is starting like this, that ABCD is a square, right? Now, as you can see, since this ABCD is a square, given a square, then in the given square, M is the midpoint of AB. So here there is certain point M, which is the midpoint of AB. So this proves that this AM is equal to BM, right? It's given. And yeah, it's also given that PQ perpendicular to CM meets AD. PQ, where is the PQ? Perpendicular to CM. So that means let us draw this line CM. This CM is the line, right? On this, a line PQ is perpendicular, right? So I'm writing AM is equal to BM and PQ perpendicular to CM. This is given to you. So this is M. So where is PQ? This should be perpendicular to CM. So on this, make an angle of 90 degree and a perpendicular to CM will be a line like this. Isn't it? So that this line is making an angle of 90 degree with this line CM. So this angle is nothing but 90 degree, right? So if this angle is 90 degree, meets AD, at P. So that means this is the point P, where this perpendicular to CM is meeting at P and CB at a produced Q. So this point, if CB is produced, then this perpendicular P is meeting here at a point which is called Q, right? Now, here we need to prove that PA is equal to BQ. To prove, we need to prove PA is equal to BQ. So where is PA? PA is this portion, right? And where is BQ? BQ is this option, this portion, right? So we need to prove this PA is equal to BQ, this one, right? So students, into this question, we can directly see that there are two triangles which are forming and PA and BQ are part of that. To solve such questions, we need to understand what we need to prove. So if this is PA, then go to the figure and see this PA. PA is a part of a triangle which you can see, triangle PMA, isn't it? This PA is the part of a triangle PMA, right? And BQ is a part of triangle BMQ, right? So this will help us to thought how to go ahead, right? So we understand that if we found some relation between these two triangles, then definitely you would be able to prove PA equal to BQ, right? So how to proceed? I am saying that in the triangle, both the triangles, if you found that yes, we need to do something in both these triangles. So let us prove the congruency of these triangles, then we would be able to prove PA equal to BQ. How? If we consider triangle PMA and BMQ. So in triangle PMA and triangle BMQ. This is the triangle BMQ. This is the triangle BMQ, right? And this is PMA. This is PMA, right? So into both these triangles, what we can see, though this angle is 90 degree, this angle is 90 degree, but whether that will help us. So to prove the congruency, what we can think, what are the congruency criteria which can be applied over here? Since PA equal to BQ, we need to prove. So that can be proved if both these two triangles PMA and BMQ will be proved congruent. So to prove the congruency of this, we can see that since AM equal to BM, this is given to you because CM is bisecting AB. So right, so we can write the first point as AM is equal to BM, right? AM equal to BM. So if you are writing the pattern of the congruency of the triangles, if it's PMA, it should be QMB, not BMQ. QMB. Why? The sequence should follow. Why I am saying it, I will explain you. If you are taking AM here, then the last two letters of this is MQ. Okay. So MQ over here is nothing but this one, and AM and MQ have no relation. So that's why when I checked, I found the sequence of the naming of the second triangle is not correct. So this will not be triangle BMQ. This should be triangle. If here is P, then the first letter of this triangle will be Q, right? It will be Q. And M in the center over here, you can see M into the center. Then here also the second will be M, right? And what will be the third letter? Definitely only one is left, that is B. So B. So that's why we consider the congruency between the triangle PMA and QMB, right? So into both these triangles, now you can see the sequence AM last two letters, and here also BM last two letters. So AM equal to BM, this is given to you, right? Now the second thing is that, do you think this is a vertically opposite angle? Do you think this is a vertically opposite angle? So from here we can see, if this is a vertically opposite angle, then we can say that angle PMA, this one, angle PMA is equal to angle, just follow the same sequence. If here is PMA, then here it will be QMB. What is QMB? QMB, right? QMB. Why that? Let me squeeze a little. These are the pair of vertically opposite angles. These are the pair of vertically opposite angles. So I'm writing it over here. Vertically opposite angles, right? Now these two angles, that means one angle here and one angle here. So angle is matching. One side is also matching, this side and this side. AM equal to BM. So into the congruency criteria, we need at least third. So what is the third criteria? After this side, after this angle, the third criteria we can see that AD and BC are parallel to each other, being an a square, right? Then we can say that all the angles of a square is of 90 degree, right? And if AB is the transversal, let us say this is the transversal, which is cutting these two parallel lines AD and CQ or CB, then definitely these two angles are equal of 90 degree because alternate, right? It's alternate. It's congruent or not that we need to prove. So here what we can see that one of the angle is equal, and here this angle is nothing but 90 degree, and here also this angle is 90 degree. So we can see that angle PAM, this one from triangle PMA, is equal to angle QBM. PMA, in triangle PMA, angle PAM. Angle PAM is this angle, which is 90 degree, this one, is equal to angle QBM, because both of these are equal to 90 degree. And how we proved it? Being an alternate angle, right? Now, since these are the alternate angles, so we can say another criteria of angle is fulfilled. So we can say that if these two angles and the side between that, right, we can write angle side angle by the congruency criteria of ASA, by the congruency criteria of ASA, we can say that yes, these two triangles are congruent. What are the angles? The angles over first is, you can consider this or vertically opposite angle, any of the angle. So angle is this much, this one, and this angle over here. Side is AM equal to BM, AM equal to BM, this side. What is the third angle? This one. So we can see by the congruency criteria of ASA, we can say that since both the triangles PMA and BMQ follow the congruency criteria, so we can say that triangle PMA is congruent to triangle QMB here. Triangle QMB, we can say both of these are congruent, and the congruency criteria which is followed is angle side angle. These two alternate angles of 90 degree, this is vertically opposite angle, and the side between them, that is AM and BM, ASA. So since these two triangles are congruent, this by CPCT, congruent part of the congruent triangles, we can say that by CPCT, what we need to prove? PA equal to BQ. So by CPCT, we can say that this P and A, this one, is equal to B and Q, right? So we can write PA, as per the sequence what we learned, PA is equal to QB, which can be written as is equal to QB can be written as equal to what we need to prove, that is BQ, right? BQ. So in this way we have proved that PA is equal to QB or BQ, and this is proved, right, my dear friends? So now let me quickly go to the second question for today. What is the second question for today? I need to see that the second question with us is that there is a, this is from trigonometry. Okay, what is the question? Let me turn it out. Yes, I put the sorts of that also yesterday. If cos 9 alpha equal to sin alpha, right? It's given to you that cos of 9 alpha is equal to sin alpha. This is given to you, right? And 9 alpha less than 90 degree. And it's also given that 9 alpha, 9 value of 9 alpha is less than 90 degree. This is given to you, right? Now what we can see that based upon these two conditions we need to find the value of, what is the value of, we need to find tan of 5 alpha. What is the value of this? This is the question to us, right? So into this question I can see, let me drop this congruency question because this question is already solved. Just a minute. Yes. So into this question, what is the requirement, how to go ahead, you need to see, right? So into this question, tan of 5 alpha. So since cos 9 alpha equal to sin alpha, this is given to you. So what we can do, so that I need to delete first, 1 minute. Is it visible? Yes, it's fine now. So what we'll do, we need to find the value of tan 5 alpha, but we are not knowing the value of 5 alpha. What we will do, since cos 9 alpha equal to sin alpha, we will be using that. Okay. I think it's visible. Sorry for the disturbance, my dear friends. Sorry. So cos 9 alpha equal to sin alpha. Cos of 9 alpha is equal to sin alpha. This is given to you. So from here what we can see, 9 alpha can't be say as equal to alpha. Why? Because here it's cos and here it's sin. So what we will do, why don't you convert this sin into cos? If you convert sin into cos, we remember one formula. Just in the cloud I am showing you it so that you can remember, right? What is the formula? Oh yeah, there was a formula. And if you write sine of 90 minus theta, it's cos theta or cos alpha. So sine of 90 minus alpha is cos alpha. Similarly, cos of 90 minus alpha is sin alpha, right? If you remember this, if you remember these two formulas, formula number 1 and formula number 2, That is the complementary. If you refer my complementary angle classes, it's very clearly explained into the two separate sessions of around 1 hour. Okay. So this sine alpha can it be written into the format of cos? Just remember this. Yes, we can use this formula. That yes, sine alpha can be written as cos 90 minus alpha. So this will show you the RHS can be written as the RHS which is equal to sine alpha. This is the RHS, right? This RHS is sine alpha can be written as cos 90 minus alpha. So just write it, cos of 90 minus alpha. So the RHS, the sine alpha of RHS is written as cos of 90 minus alpha using this, that is cos 90 minus alpha, right? Complementary angle concept. And into the LHS, we have already cos of 9 alpha. This was your LHS, cos of 9 alpha. So from here we can say that cos of 9 alpha is equal to cos 90 minus alpha. So this will prove that, this will show you that when the cos of both the angles are taken, right? When the cos of both the angles are taken, the benefit of that, if you take the arc sine, that means if you remove the cos, then this 9 alpha will be equal to 90 minus alpha. Then 9 alpha equal to 90 minus alpha, right? This will give you 9 alpha plus alpha equal to 90, and this will give you the value of alpha, 10 alpha equal to 90 by 10. So the value of alpha is calculated as equal to 9, right? Now the value of alpha is calculated as equal to 9, and we need to find the value of tan 5 alpha. So what is the value of tan 5 alpha? Tan 5 alpha is 5 times alpha, that is 5 into 9, and 5 into 9 is nothing but 45. So what we are going to do, we can simply write that if alpha is calculated as equal to 9 degree, right, then we need to find the value of tan 5 alpha. So this is basically tan of 5 into this 9, right? So this will give you tan 5 into 9 is 45. And what is the value of tan 45 degree? Tan 45 degree is easily known to us. That is equal to 1. So the value of tan 5 alpha is calculated as equal to 1, right? So in this way, my dear friends, we can see we have solved the second question of trigonometry which we have taken for today's session, and the shorts of this is already I put into my channel yesterday. Okay, so you can see the explanation how such questions can be solved. Okay, I'm just taking conceptual questions and possibly that they will help you into your examination. Okay, so if for any queries you can come up, okay, and you can come up with your comment and any such doubt, and just be connected. I will be there with you. I will try to come up with a separate live session also. But we have taken two questions. This is the question number 2 for today, and the question number 1 which we have taken for today, this one, they are a square extended like this, BM CM perpendicular to PQ. We have just proved PA equal to BQ, and these are the steps which are followed after proving the congruency. We just did it. Okay, so let me wind up that session for today, my dear friends. Let's correct into the next session. Thank you so much. Take care. Bye bye.